Hello friends, welcome back to all about structural analysis and design. So in this video we shall see how to calculate the shear force and bending moment for a overhang beam. So in my previous videos we have seen how to calculate shear force and bending moment for cantilever beams with different loads, and also we have seen the simply supported beam with point loads and UDL. So today's video will be about this overhang beam, and also I will tell you what is meant by point of contraflexure and how to calculate the point of contraflexure in this particular video. And also we will calculate the maximum ordinate of bending moment when shear force changes its sign from negative to positive. So all the salient features of this shear force and bending moment has been covered in this video. So this video might get long, but watch this video completely to understand all the basic concepts of shear force and bending moment. So this is the beam given to us, which is having three spans. AC is one span, CB is one span, and BD is the last span, and BD is the overhang portion. So this overhang portion is having 6 kilonewton, and the first span AC is having 20 kilonewton per meter UDL acting at a 2 meter span. Okay, so the total span of the beam is 6 meters and it is divided into 2 and 2 meter spans. So for proceeding this shear force and bending moment problem, we have to find out the reactions RA and RB. So A is having hinge support, B is having roller support. So we need to find out the reactions RA and RB before proceeding the problem. So for that we need to first draw the what you can say for free body diagram. Okay, so this will be RA, so this will be RB, this is overhang portion 6 kilonewton. Okay, so this is your UDL 20 kilonewton per meter, and these are the spans 2 meter, 2 meter and 2 meter. So this is the free body diagram of this particular beam. Okay, so we need to calculate now RA and RB before proceeding to the shear force and bending moment. So for this thing you can either have the moment about A or you can have the moment about B. So I will be calculating the reactions or taking the moments about this point A. So taking moments about A. So therefore it will become sigma MA equals to 0. Okay, so sigma MA is equals to 0 because we are taking all the moments about A. So now this 6 kilonewton is moving at a particular point A at a distance of 6 meters, 2 plus 2 plus 2. Okay, and it is moving clockwise. So our sign conventions, if you have seen my videos, okay, so the moment if we take from left hand side clockwise is positive, and if we take from right hand side anti-clockwise is positive. It is based on sagging and hogging. Okay, so this 6 kilonewton is moving now clockwise, and we are taking the sections from the right hand side, not left hand side. So right hand side anti-clockwise is positive. So now this is moving clockwise direction. So the 6 kilonewton will be moving at a distance of 6 meters. Okay, in about point A in clockwise direction. Clockwise directions means it is negative because we are taking anti-clockwise as positive. Okay, so this will become minus 6 into 6. Okay, so this 6 kilonewton is moving at a distance 6 meters. Because it is moving clockwise, so I have written minus. And then this RB is rotating at a distance of 4 meters anti-clockwise now. Okay, so this is moving at a at about A clockwise. So this anti-clockwise. So this is known as positive RB. Why positive? Because anti-clockwise direction is positive. RB is rotating at a distance of 4 meters, 2 plus 2. And this is UDL. As you know, this UDL has to be converted into point load, and this point load will act at the half the distance of this particular 2 meter span. So it will become, if you want to convert it into point load, then it will become 20 into 2, and it is moving again in clockwise direction. So it becomes minus. So 20 into 2 acting at a distance of 1 meter. Okay, it will act at the center. So this is equals to 0. So this is very important. while calculating the reactions. So now it becomes, so RB will keep it as it is equals to, we'll keep, or we'll send this 6 other side, so it will become positive. So 6 into 6 is 36, and 20 into 2 is 40. So RB into 4 equal to 76. So RB is equals to 76 divided by 4, it will become 19 kilonewton. So RB is now 19 kilonewton. Okay, so we have got the first reaction RB. Now we have to calculate RA. So RA is positive because it is moving upwards. Then minus 40, this 20 into 2 is 40, then plus RB, then minus 6 equals to 0. So RA equals to 40 minus 19 plus 6. So RA is 27 kilonewton. So now you have got both the reactions. So reactions, this is RA is equals to 27 kilonewton and RB is equals to 19 kilonewton. So now you have the reactions. Now you can proceed for the shear force and bending moment calculations. So before moving on to this shear force and bending moment calculations, first we will write the sign conventions. So this will be the sign conventions for shear force, and this will be the sign conventions for bending moment. So if you are taking from left hand side, shear force will be positive upwards. If you are taking right hand side, the downward force will be the positive, and if you are taking from left hand side, clockwise will be positive, and right hand side anti-clockwise will be positive. So this you have to clear it. Okay, so then now we will go span by span. So I will be coming from this right hand side portion. So I will be taking the portion BD for span BD. Okay, so now what I will do, I will just take that span which is having 16 kilonewton load. So I will mark it as XX section. So and it is acting at a distance of X. Okay, this 6 kilonewton is acting at a distance X. So now we will calculate the shear force. Shear force I will denote it as Fx. And for point load there is no question of again X for shear force. So and we are taking the from right hand side, and from right hand side the downward force is positive and 6 kilonewton is moving downwards. So Fx is positive 6 kilonewton. So this is your shear force. Now the bending moment we shall calculate, and we'll see how it changes, and we will denote it as Mx. So Mx will have now the equation which is which will incorporate this X. Moment is nothing but force into distance, and we are taking it from right hand side. Right hand side anti-clockwise is positive, but this 6 is moving in clockwise direction. So minus 6x. So it will have two values. One is at 0 meter and another value at 2 meter, because this section is or the span is BD. So BD, the starting point is 0 and the end point is 2 meters. So at x equals to 0 meters and x equal to 2 meters. So 2 mx or 2 moment values you have to calculate. So 6 into 0 is 0 kilonewton meter, and 6 into 2 is minus 12 kilonewton meter. So this is how you calculate the shear force and bending moment for span BD. Now we shall proceed to the span CB. Okay, this is completed. Now we are moving to CB. Now for span CB. Okay, now what will happen, we shall take only those spans. So now while taking CB, BD also will come into picture. Okay, so this is your XX and this is your 6 kilonewton. Okay, this is your RB. RB is how much? 19 kilonewton. Okay, and there is no load again in between CB, so we shall not have any load in between. So this total entire thing is X okay, and again this is divided into two parts. So this BD span was 2 meters, and this will become x minus 2. So this span is x minus 2. Now the effects will be shear force for this CB. So this is moving downwards, so it is positive, and this is moving upwards, and from right hand side upward is negative. So 6 minus 19. So Fx will be minus 13 kilonewton. Okay. Now we shall calculate the bending moment mx. Mx, the 6 is moving at a distance of x. So this will become minus 6x. Okay. Now this 19 is moving anti-clockwise direction. This anti-clockwise is positive from right hand side. So plus 19 x minus 2. Now at x equal to 2 and x equal to 4. Why 2 and 4? Because this span CB starts at a distance 2 meters and ends at 4 meters. Okay, so we are coming from this right hand side. So this was 0, this was 2, so BD was having 2 meter span. CB is again having 2 meter span, but we are coming from right hand side, so it will become 4 meters. So the CB, the starting point is 2 meters and ending point is 4 meters. Okay, so at x equal to 2 and x equal to 4. Now you have to substitute in this and you will get the value mx equal to minus 12 kilonewton meter. Okay, just check the values. So at x equal to 2 minus 12 kilonewton meter, x equal to 2 minus 12 kilonewton per meter, and at x equal to 4 mx will be 14 kilonewton meter. Okay, now if you see what happens is the CB, otherwise I will just get back to this particular point of contraflexure in this next step. So first we shall see all the spans. Okay, now for span AC. Okay, now you have two options. Either you can come from right hand side or you can come from the left hand side. If you come from right hand side, the calculations will be more, and if you choose to come from left hand side, the calculations will be less. It depends upon you which hand side you have to take. So to make the calculations simpler, I will take from this left hand side for this span AC. Okay, so I will omit this from right hand side, coming from this right hand side portion, and I will take the left hand side for this span AC. Okay, so we shall have this. So if you come from left hand side, the section will end here, so this will become XX, and the reaction is RA, and RA is 27 kilonewton, and this is having a UDL of 20. Okay, and this is the distance X. Okay, so we are taking section at the between AC, so it is having the complete UDL for this span. And for this again we have to calculate shear force. Fx equals to, now shear force, if you are taking from left hand side, positive is upward, so this 27 is upward, so it becomes positive, and this 20 is negative because it is moving downward, so minus 20x. Okay, this so this 20 is UDL, that's why the x comes into picture. Now you have two values at x equal to 2 and x equal to 0. Okay, this span is starting at 0 and ending at 2. So why we are taking from 2? Because it will be easy to compare these values. So at x equal to 2, if you substitute here, so you will get Fx equal to minus 13 kilonewton, and this Fx will be 27 kilonewton. Okay, now you can compare. So at x equal to here this one it was minus 13 and this is also minus 13. Then it becomes my 27 kilonewton. That's why I have taken 2 at the top. So the last part remaining is this bending moment for the span AC. So mx equal to, now this 27 is rotating clockwise, and if you are taking this left hand side, clockwise is positive. So 27 into x, okay, minus this 20 is acting at a distance x into x by 2. So this is UDL. We have to be careful while taking the bending moment. 20 into x will be the point load and it will be acting at the center of that particular span x. That's why it is x by 2. 20 into x by 2. And again it will have two values. So x equal to 2, x equal to 0. So mx is again 14 kilonewton meter and mx is 0 kilonewton meter. Okay, so if you substitute 2 in this particular equation, you will get mx 14 and 0. So again, if you compare here, at x equal to 4 it was 14 and at x equal to 2 means again here at this point it is 14, so it is matching. So this is how you calculate the shear force and bending moment. Now we shall see how to calculate the point of contraflexure. So point of contraflexure is nothing but when the bending moment changes its sign from negative to positive or positive to negative. So we have to see where the bending moment is changing its sign. So the bending moment was at the first span it was 0, then minus 12, and the second span it is minus 12, and the next value at x equal to 4 it is 14. So the bending moment is changing the sign from minus 12 to positive 14 at span CB. So the bending moment is changing the sign for this span CB. Understood? The point of contraflexure is nothing but when the bending moment changes its sign from negative to positive or positive to negative. So we have to check in this problem where the bending moment is changing its sign. So again I will repeat. So span BD it was having 0, then minus 12. For spans PB it was again minus 12 and then it became positive 14. So it means the bending moment is changing its sign from positive to from negative to positive for a span CB. So CB is the span which is having a point of contraflexure. So it means we have to find out that point for that span CB. So finding out that is to make this equation, to make this mx equation, moment equation equals to 0 and finding out that x value. Okay, so I will just show you how to calculate. So that mx equation you have to equate it to 0. So this mx equation was mx equal to minus 6x plus 19 x minus 2. Okay, that we have to take to calculate point of contraflexure. Okay, point of contraflexure lies in span CB. So taking the moment equation of CB, so the moment equation was mx equal to minus 6x plus 19 x minus 2. So it became mx equals to minus 6x plus 19x minus 38. So this was 19 into x and 19 into 2 is 38. So Now what you have to do, so we have to take this moment 0. Why moment 0? Because it is changing from negative to positive. When it changes from negative to positive or positive to negative, it means that bending moment is 0. So now 0 equals to minus 6 and plus 19 is 13x minus 38. So 13x equals to 38, x equals to 38 divided by 13, which comes out to be 2.92 meters. So x equals to 2.92 meters. Okay, remember this is from right hand side. If it is coming from left hand side, then that equation you have to take, okay, and you have to calculate the x. So from, if you calculate from left hand side or right hand side, it doesn't have any difference. So the x value is 2.92. If you take from right hand side, the value will be slightly larger, okay, it will be more than 3. And if you add that, if you calculate that also, it should come at 6 meters. So because the total span was 6 meters. So this is how you calculate the point of contraflexure. And one more, the maximum bending moment ordinate also we have to calculate. Why? Because the shear force also is changing the sign. If you have seen here in the calculation, so the first was positive, then it became negative, okay, and from negative again it became positive, okay. So where it became negative to positive, because again it was here UDL, carrying UDL, so it became negative to positive. So it means the bending moment ordinate you have to calculate for span AC. So for span AC you have to take this equation and you have to equate it to 0, find out the x, and then find out the value of that particular bending moment after inputting that x value in this mx equation, okay. So that I will show you. So this was a point of contraflexure. So the next calculation will be to find out maximum ordinate of bending moment. Maximum ordinate of bending moment at span AC. To find out that, first you have to take the find out the x value, and x value you can find out from this shear force equation. So 27 minus 20x minus 20x equals to 0. So 27 minus equal to 20x. So x equal to 27 by 20, which comes out to be 1.35 meters. And you have to take now the moment equation. This moment equation you have to take 27x minus 20 into x square by 2. So it will become, therefore 27x minus 20 into x by 2, so equals to 0. So that x you have to substitute here, 1.35. So 27 into 1.35 minus 20 into 1.35 into 1.35 divided by 2 equals to 0. So that comes out to be 18 point this was mx. You have to find out the bending moment, okay. So mx comes out to be 18.225 meter. So this was the distance, and this is the maximum bending moment value for this particular 1.35 meter ordinate. This is how you have to calculate. Now at the end you have to draw the SFD and BMD. So this is how the SFD and BMD looks for this particular problem. So this was overhang. It was having 6 kilonewton at the end, 20 kilonewton per meter. So now you can have the clear idea. So the shear force was 6 kilonewton, okay. So then it moved to negative 13, and it continued again till 13 here because there was no load again. And from this 13 to from this particular C to A, it changed its position. So shear force changed the sign from negative to positive, okay. In between it crossed. Here it didn't cross, means same particular B it crossed. That's why we didn't calculate again the x, okay. So now this you have to find out the first x value, 1.35, the calculation which I have shown the just now. That x was 1.35 meter, because we don't know at exactly how much distance this shear force is changing the sign from negative to positive. That's why we made that shear force equation equals to 0 and calculated the value x, that is 1.35 meter. And that particular x value we substituted in moment equation for AC span and got the value as 18.225 kilonewton meter. So this is how you calculate the maximum bending moment ordinate when the shear force changes its sign from negative to positive or positive to negative. And the point of contraflexure was at the span CB. Just see here, it is changing from negative to positive. So first it was 0. So these are the 0 positions. So it was 0, then it became minus 12 kilonewton meter, and then it suddenly changed till 14. It became from minus 12 to positive 14. So it changed the sign. So somewhere here the bending moment was 0, and this was point of contraflexure. That's why we have taken the moment equation of CB span, and that we have equated to 0. Okay, why equated to 0? Because at this particular point that moment will be 0, and for that the distance was 2.923 meters. The distance was 3.077 meters if you have taken from the left hand side. Okay, so from right hand side we have taken, it became 2.923. So at that distance 2.923 meters, the bending moment will become 0, and this point is known as the point of contraflexure. That's why we take the CB moment equation, and it is equated to 0, and we calculate the distance. Okay, so at this distance the moment was 0, that's why we calculate this 2.923 for this particular problem. So this was point of contraflexure, and this was the maximum bending moment ordinate when the shear force changes its signs from negative to positive. And this point of contraflexure was changing from negative to positive, and that distance was 2.923 for that particular bending moment, or that particular 0 bending moment value. Okay, so this is how you calculate point of contraflexure and the maximum bending moment ordinate. So these are the all, or you can say these are the all the silent features of this particular shear force and bending moment chapter. So if you have understood this video, please like it, share it, and don't forget to subscribe all about structural analysis and design, and also press the bell icon for the latest notifications of my videos in civil and structural engineering. Thank you friends.